Today, mathematicians will be adding fractions with unlike denominators. Unlike just means that the denominators are different. They're not the same. For example, here we have 2/3 or 2 1/3 plus 1/4. 3 and 4, they're not the same denominator, and so we cannot add them together in their current configuration. See, that I've got 2 1/3 here and 1 1/4. So I see how long that is, but I don't know what to call that fraction because they're two separate denominators. They're two different units. So what am I going to do? Well, you need a three-step plan when you're adding fractions with unlike denominators. First, you have to find a common multiple of both denominators and then rename each fraction with the common multiple as the denominator. Then you can add them. Don't worry, we're going to go through each of these steps. So first, if I'm trying to add 2/3 and 1/4, I need to find a common multiple of both denominators. So find a common multiple of 3 and 4. Why is that even important? It's important because you can't add fractions unless they're the same unit. Like I can add 1/3 plus 1/3, just put them together, that's 2 1/3. How about adding 2/5 plus 1/5? Well, sure, I can do that. They're the same size piece. The denominator is the same, so that's 3/5. But if you have different denominators, like if I tried to add 2/3 to 3/5, well, I don't know what to call that fraction because I've got different sizes. So why do I need to find a common multiple? Well, if we look at this fraction equivalence chart here, let me look at 1/3 here. I'm going to look down this line and it'll show me everything that 1/3 is equivalent to. 1/3 ends right here at this line. So if I just follow that line down, it'll show me everything 1/3 is equivalent to. I'm just going to block off with this paper. So 1/3 is equivalent to 2/6, 3/9, and 4/12. But it's not equivalent to any amount of fourths. See, if I pull this away, this 1/3 line, it goes right in between these fourths and right in between this fifth here. But it is equivalent to sixths, ninths, and twelfths. Well, 3, 6, 9, 12, those are all the multiples of 3. 3, 6, 9, 12. So I can rewrite any fraction that's in thirds as sixths, ninths, or twelfths. Those are the multiples of 3. Likewise, we were looking at fourths before. If I look at 1/4, 1/4 cannot be written as fifths because it splits this fifth. It can't be written as sixths. But it can be written as eighths. There's a line right here that equals the line here for 1/4. So 2/8. It can't be written as ninths or tenths, but it can be written as 3/12. So I can write fourths as eighths or twelfths. So here are the multiples of 3, and here are the multiples of 8. Do you see any they have in common? Sure, 12. I can write 1/3 as 3/12, and I can write 1/4 as, 1/3 as 4/12, and 1/4 as 3/12. So I can write both thirds and fourths as 12ths. That's why we need to do step 1, finding a common multiple of both denominators. That's what we've done. So 12 is their common multiple. Next, I just have to rename each fraction with the common multiple as the denominator. So let me do that. I'm going to rewrite both 2/3 and 1/4, but in twelfths. So how many twelfths is equal to 2/3? I'll start by showing this with fraction tiles. So I have 2/3 here, and I'm just going to add a bunch of twelfths until I equal the length of this bar. So I saw 4/12 fit in 1/3, so we should get 4 more twelfths in this other third. And yes, sure enough, 8 1/12 make 2/3. They are the exact same. So you can also do this with math. 12ths are 4 times smaller than thirds. So if I want the same amount of a whole, I need to multiply the numerator by 4. I need to have 4 times as many pieces. 2 times 4 is 8. So you can see 8/12 equals 2/3. They are the same. So what about this 1/4? I'm going to turn 1/4 into 12ths. So that's just 1/4, and it looks like 3/12 fit in 1/4. So we can show this with math as well. 12ths are 3 times smaller than fourths, so we need 3 times as many pieces to make an equivalent fraction. So 1/4 is equivalent to 3/12. So what we've done is just renamed these two fractions in the new denominator, the new denominator of 12, which was the common multiple that they had. The last step is to just add them. You know now that you can add fractions that have the same denominator. So I'll show that with the tiles first. We renamed 2/3 as 8/12. And we renamed the 1/4 as 3/12. So that's a lot of 12ths. 8/12 plus 3/12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sure enough, 8/12 plus 3/12 equal 11/12. So that is our sum, 11/12. First, we needed to find a common multiple of both denominators. We did that. Over here, we found that a common multiple of 3 and 4 are 12. Then we renamed each fraction with the common multiple as the denominator. We renamed 2/3 to 8/12. We renamed 1/4 to 3/12. And then finally, we just added those renamed fractions. We got 11/12. We're going to do one more example. So here I have written 3 fractions with different denominators. We have to follow the same steps, though, that we did before. First, find a common multiple of, I wrote both denominators here, but all the denominators in this case, because I have 3 denominators, I need to find a common multiple of 2, 4, and 8. So first, let me write the multiples of 2. 2, 4, 6, 8, 10, 12, 14, 16, etc. Now the multiples of 4, 4, 8, 12, 16, 20, and now the multiples of 8, 8, 16, 24. So I see a few multiples that we have in common here. I see 16, but there's a smaller one. It's always easier to go with the smaller common multiple just because smaller numbers are usually easier to work with. And I see that they all have 8 as a common multiple. Now this is really nice because one of the denominators is already 8, so I don't even have to rename that one. See, our next step, step 2, is rename each fraction with the common multiple as its denominator. But that fraction already has 8, so haha, that's less work I have to do. So let me rename these with a denominator of 8. Like I said, I don't have to rename this one. It already has a denominator of 8. So let me rename 1/2 a certain number of 8s, and then I'll rename 3/4 a certain number of 8s. Let me just use mathematics here instead of pulling out the number tiles, the fraction tiles again. 2 times 4 is 8. That means 8ths are 4 times smaller than halves, so we need 4 times as many pieces to make an equivalent fraction. 1/2 is 4/8. Here, 8ths are 2 times smaller than fourths, so I need 2 times as many pieces to make an equivalent fraction, and 3 times 2 is 6. So my new fractions are 4/8, 6/8, and I didn't need to change this one. So now step 3 is to add the renamed fractions. So I will do that. 4/8 plus 6/8 plus 3/8. And I know I've got the same unit, so the units are going to stay the same. 4 plus 6 is 10. 10 plus 3 is 13. 13/8. So that is the correct sum, but you can also write this fraction in another way. Do you see it? It says 13/8. That means we have more than one whole here. Let me make a diagram of this. So this is one whole, and the denominator tells me there are 8 parts in a whole. So there are 8 parts there, but I have 13 pieces, so that is more than that entire whole. So I'm going to need a second whole and split that also into 8 pieces. And then it says I have 13 of them, so let me shade in 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So here I have one whole, or 8/8. 8/8 in parentheses, run out of room there. And here I have 1, 2, 3, 4, 5/8. So I can also write 13/8 as 1 and 5/8. That is the sum of 1/2, 3/4, and 3/8. Okay, when you're adding fractions with unlike denominators, just follow these 3 steps.